So welcome to Basic Statistical Literacy. My name is Morgan. I'm a clinical and instruction librarian here at the Savitt Medical Library with UNR Med. And I wanted to do a session like this, mostly because I have a background in statistics, but also, statistics is a lot. It can be really overwhelming. And so any amount of resource that I can give to make it more simple for you or anyone that you're working with is my goal. But you're probably wondering what even is statistical literacy, so I can get into that. And today's session will cover basics like the difference between population and sample, sampling methods, different types of variables, and then we'll go over an article together. And then I have another session scheduled for next week, which will get into more of the nitty-gritty with hypothesis testing and distributions and an article example as well. But this one will be kind of the basics, as it says. So statistical literacy, I made a brief definition of for myself, which is just the comprehension of statistical analysis and processes that assists in the understanding of broader information. So similar to information literacy, being able to digest, what might fit your needs, what might not. But with statistics, I think being a little bit more critical about it. I feel like many of us, when we read an article, if maybe the concepts are not something that we're familiar with, we tend to take the author's word for it, which sometimes the author's word is not fully, I think, where it needs to be in terms of statistical analysis. And so having that background, being able to understand what they're talking about and how, and determining what fits your needs and what doesn't. So I am not here to give you a crash course on everything statistics. That would take a very long time. I have a 4-year degree in statistics. I don't even consider myself a statistician. So it takes a long time to build up that knowledge. But what I do want to do is kind of give a toolkit for a form of critical appraisal in a way of being able to read and disseminate information with statistical analysis included. So the first thing I wanted to cover is what even is statistics generally. So 2 words that sometimes are used interchangeably that mean different things are data and statistics. They're best friends, they walk hand in hand, but they are not the same thing. Data is a lot more high concept because data is information. So data can be that spreadsheet of numbers that you probably picture when you think of the word. But it can also be just you maybe sitting in the room that you're at and recognizing what colors the items in front of you are. That's information. Maybe recognizing that you skipped breakfast, you're feeling a little hungry. That's information, that's data. So data itself kind of exists in this kind of liminal space. Statistics is more so a practice. So statistics is how we collect, analyze, and interpret that information. So it's how we go about understanding that data and really getting into the nitty-gritty of the information. So I put these little icons up there of the bug and the magnifying glass of the bug, because if data was the insect, statistics would be entomology, is how I would phrase it for you. You'll also notice that this is statistics capital S, as in the concept. Later on in the slides, you may see statistics lowercase s, and I'll explain the difference between those two. But first, I feel the need to really go over the difference between populations and samples. So these are words that are thrown around in statistics, but to give you an overview, population is your entire group of interest. So statistics is really a way that we answer questions, whether descriptive or inferential. So whether you're just trying to get a lay of the land of what this information is and what it's saying, or if you're actively investigating something, you're still answering questions. And your population is the entire group that that question is about. So if you were doing a project on, say, pediatric leukemia patients, your population would be every single pediatric patient with leukemia ever existing, which is way too much for any one person to go out and survey or study or gather information from. Even if you condense that to just maybe the US, that's a lot of patients. That's a lot of information. So samples come in as a subset of that group because our goal in statistics is answering these population-sized questions with a sample size of work. So your sample is going to be maybe instead of every single pediatric leukemia patient, you're looking at maybe just 100 survey responses. That's a lot easier to work with than millions of individual patients. So your sample is kind of your door to answering those questions. And samples are obtained through different methods. So there are different ways that you can collect that information and kind of determine who's included in that group. But the main takeaway from population and samples is when you're reading a study, or if you're engaging with information, and you start to kind of think to yourself, what might their population be? You're ultimately getting the information of what question are they asking. And if their population differs from what their stated question is in the article, you might start to ask yourself, why did they choose this population? If their question is explicitly this, why are they using this? So kind of doing your independent investigation as to what exactly their population is and why they chose it can indicate what actual question they're asking and answering. Now, I mentioned that samples are taken from different sampling methods. They usually fall into two different categories. We refer to them as probability sampling or non-probability sampling. The word probability basically just refers to, is every person included or every object included in your sample equally likely to be chosen? So if you have like a bag of M&Ms, is every single M&M equally likely to be included in the handful that you grab out of it? Or are the ones at the top more likely to be chosen? Or do you find that subconsciously your hand is gravitating towards the green ones because your favorite color is green? And that kind of determines the difference between probability and non-probability. So probability sampling, the main way to indicate that that's what's being used is this word random. If there's any type of randomization happening, like a random number generator, that's indicating that the items included in the randomization are equally likely to be chosen. So probability sampling is occurring. With non-probability sampling, typically the most common one is convenience sampling. So that's like if I was doing a study, my population is medical librarians in the US, and I give a survey to my coworkers at my library. That's not a sample of every medical librarian in the US, it's a sample of librarians at my library. But they're just the easiest, they're the most convenient to access. So I'm introducing the bias of these are librarians that only live in Reno. These are librarians that I work with that engage with the same students that I'm engaging with. So it's not as representative of every librarian in the US as it should be, because I'm just accessing who I have right here. So it's that introduction of bias. It's that introduction of maybe these outside factors that could be influencing whether or not someone's more likely or less likely to be included. That makes it non-probability sampling. And the main conclusion here is whether it's probability or non-probability affects what types of conclusions you can make. So if you have non-probability sampling, you can't really make these huge sweeping conclusions about your population because your sample is not representative of your population. You have a sample that's representative of a subgroup, but you can't say every medical librarian in the United States has this opinion because the medical librarians at my library said this. That's not a conclusion you can make. So keeping an eye out for that randomization and noticing what conclusions they're making, just to see if they even have the methodology to warrant the conclusions that they're making is important. I will also point out one of these non-probability sampling methods is purposive sampling, and that opens the door to the more nefarious side of sampling methods, which is confirmation bias. So you have a conclusion you're trying to make, so you sample people or things that will uphold what you're trying to argue. So maybe you're trying to do a poll of opinions, so you only sample people who agree with your opinion. That would be a purposive sample. And that is a huge kind of ethical statistics no-no because you're not actually representing a population, you're representing your opinion. So keeping an eye out for some of those ways that unfortunately, people like to be sneaky and they like to make points and they'll do whatever they can to make that point. And now you know to look for it, which is my goal. So another piece too is variables. So variables, you may have just heard things referred to as variables. What that means is it's a category of characteristics that something has. So a variable with people, usually in health sciences data, you'll see age as a variable. You'll see height, weight. You'll see maybe vital signs, blood cell count. You'll see specific categories of a characteristic. And they usually fall under two categories. Stats loves a two-category system, as you'll notice. And that's usually numerical and categorical variables. Numerical are what we expect to see. Those are those numbers. Those are, age, height, weight, which fall under two different categories, usually just referring to whether it's a whole number or if it's between two numbers and includes like a decimal to it. So a discrete variable is one that's a whole number. We don't measure age in decimals usually. We don't say you're 27.6 years old. So it would just be discrete data. It would just say 27. Continuous variables are those decimals that's in between two numbers. So height and weight usually end up being continuous. Anything like vital signs would probably be continuous as well. We like to be as specific as possible. And then categorical variables are essentially the numberification of things that aren't usually numbers, if that makes sense. Things that are like sex designation, things that are like a true-false question, yes or no, agree, disagree, those types of things can be numberified into categorical data. So nominal data would just be, like I mentioned, sex designation, so an M or an F or a 0 or a 1. Ordinal is still that kind of true false concept, but it has a kind of natural order that it should follow. So if you're doing like a Likert scale on a survey, you don't want to reorder it from disagree, neutral to agree. If you reorder that, it doesn't really make sense. So it has to keep kind of that natural order that it has, and then that would be ordinal data. So with this being said, I don't necessarily expect anyone to go out and start identifying what variables or what type, but it just kind of gives you an understanding of how this type of data is organized and represented. And there are different ways that you can visualize data depending on what type of variable it is, and different ways that you have to go about like methodology-wise and mathematically. If you decide to compare two of them, and there are two different types of variables, there are things that you have to take into account. So understanding how these numbers or values are going to be organized will help kind of digest that information. So that is just a little vocabulary toolkit for you. Then I think probably the piece that intimidates a lot of us the most is notation. Notation can get really out of hand in statistics really quickly. You get a lot of these big, scary Greek letters, a lot of these really complicated equations that include all of this superscript and subscript. And I included this slide. I don't necessarily want you all to memorize all this information, nor do I expect you to have a cheat sheet ready to go all the time. I still have to Google stuff regularly because I forget what specific Greek letter refers to what. But I can give you kind of a by and large, especially with this basic descriptive statistics like mean, median, variance, standard deviation. Typically, those big imposing Greek letters, the capital letters, refer to something involved in the population. So your population, this like big scary concept, again, lots of data points happening, that's usually referred to by the bigger figures, the bigger notation. Whereas your sample, and this is what I mentioned, the lowercase statistics, statistic as an object is just a number from your sample. So the saying like, I don't want to be a statistic, you don't want to be a number in the grand scheme of things, not the capital S concept, but the actual object. But with samples, you're typically going to see lowercase, you're going to see smaller letters, you're going to see a lot of superscript referring to things. So X bar is your sample mean. And these smaller letters, most of the time, not all the time, these smaller letters will refer to the sample. Now, when you get to more like complicated concepts, that's going to change. And capital, lowercase, big, small is not really going to matter. It's just referring to some other big concept. But with these descriptive statistics, that tends to be the trick, is just if it's big and imposing, it's probably referring to the mean or to the population. And as you'll see with these variance equations, how you go about writing and structuring a lot of these calculations is going to change between population and sample. So knowing that if something is coming from the population, that math is almost entirely different from the math that you would do for the sample. So them making a claim that, you know, this is coming from the population holds a lot of weight and significance. Those big capital scary letters are them taking a stance that they've estimated something from the population, not even their sample. So with notations and symbols, they're indicating what's being discussed or analyzed, but they're also indicating what the significance of this conclusion might even be because of whether it's coming from the population or sample. And that is, I think, the main thing to take away from notation. Again, it's still going to stay a little bit overwhelming, but just knowing that there is usually sometimes a method to the madness, but again, once you get to complicated stuff, they, you know, no holds barred. So they go crazy. But all those concepts being covered, now I wanted to go through an article. And I'll share my screen, but I will also maybe copy this link into the chat for you all. Let me go back. Oh no. Okay. Just so that you have it if you would like. I will put that in the chat. But this article is fun for me because it is not at all, I think, super serious. It's very tongue-in-cheek, I would say. But it is a Journal of Pediatrics and Child Health article called Everything is Awesome, Don't Forget the Lego. And I wanted us to take the concepts that we talked about today just to kind of get a deeper understanding of what is actually going on, because while the article is pretty tongue-in-cheek, they do make some conclusions that I would be curious if you all from the content today think that they're allowed to make. So the quick and easy summary of the article is they were doing a study on how long it takes for ingested foreign bodies to pass through and be found in fecal matter. Specifically, they kind of H. pylori-esque experiment had a bunch of physicians swallow Lego figurine heads, and they studied how long it took to digest that out. And they gave them scores on how long it took them to find this Lego head and digest it. And you'll notice in the methods section that they say here 6 pediatric healthcare professionals were recruited to swallow a Lego head. They were excluded if they had previous gastrointestinal surgery, an inability to ingest foreign objects, or an aversion to searching through fecal matter. But overall, any pediatric healthcare professionals were allowed in. Of those 6, let me go down to this methods. We'll skip back up, but this bigger method section does discuss that the 6 participants were recruited from an established discussion forum related to an educational website that the authors were associated with, which I would be curious, you can unmute yourself or put it in the chat, what type of sampling method you all think that this is. Yeah. I would argue either convenience, or I didn't really go into snowball sampling, but snowball is kind of an expanded form of convenient sampling where you do a convenient sample and then you say, okay, you guys tell your friends, and it snowballs to just like different convenient samples within each other. So with a forum like that, it could have done that, and then they ended up with 6 people who were willing to participate. But either way, we know that this is non-probability sampling, so we should keep an eye on what types of conclusions they're making. Then they go through kind of how they scored these different things. You'll notice that the score acronyms are very unserious. They really had fun with this one. But then in this table, you'll see they have some descriptive information. So the age range of the participants, the sex designations of their participants, and then the scores that they had. So you'll see discrete variables, you'll see that nominal variable there, discrete again, and then these ones are continuous, even though you'll see that there are some whole numbers here, because there are other numbers within the variable that are continuous. You would probably usually just do a 3.0 there to make sure everything's formatted the same, but that would be considered a continuous variable. But you will notice here that they said that patient B was unable to retrieve the Lego head. So they have an NA for several of these variables. In that case, their overall sample size is 6 people, but for these specific variables, they would have to do any analysis or calculations with a sample size of 5, which with something this small isn't a huge difference. But if you say do a survey and you have a sample of 150 people who received this survey, you know that they received it, but only say 65 people fill it out, and you have a large non-response rate, that means that your sample size went down from 150 to 65, and that's something huge to take into account. So I'm glad that they noted this, but again, it doesn't make a huge difference here. It's just something to keep track of if you notice it in other studies that maybe their sample size will change. And they do use that lowercase n, indicating that their sample size is different. It'll change from 6 to 5. And then here, you'll notice that they mention something that we didn't cover today, which is testing and significance. Here, they're not necessarily referring to significance as like a whether or not they think it's significant. They're referring to statistical significance, which has to be mathematically determined. But that is a little hint that that's something I can cover next week if you're so interested. But they did do this test, and you'll notice they visually represent this in a way that's appropriate. Though I think with their continuous variables, personally, I would have preferred if they had, I think, a little bit more explicit of a range in between these to fully understand it. But I think overall, they did a good job with visualizing it. But I will show you both in this conclusion section and all the way back up here at the top, they noted what this study adds. And their conclusion here says a predefined object passes through adult patients in 1 to 3 days, which is not technically incorrect based on their data. But again, they had a convenience or snowball sample of 6 people that were, you know, that's not representative of the entire adult population. If they're just saying adult patients, that's every adult ever. I don't necessarily think that this wording helps them much. And maybe rewording it as, you know, our sample had an average of a passing between 1 to 3 days, and just really focusing on our sample did this. These sweeping generalizations about the population aren't super appropriate with their sampling method and sample size. But, you know, the conclusions that they made were good. And I think overall, you know, it does serve as a form of reassurance for parents that, you know, on average of these 6 professionals, 1 to 3 days tended to be how long you had to wait for it to pass. But again, these kind of generalizing statements about a population that they didn't really represent fully, I think I would be concerned about. But overall, I feel like that context itself helps a little bit to understand the article and what they were saying. And that is all I have for today. We have a couple minutes left, though. If anybody has any questions, I will re-share the slides here. But that is a good one. But if anyone has any questions or comments, or if there's anything specific that you learned today that you're excited about, I would love to hear it. And then I will change the slide here. And I hope that if you have time, you can join us next week. I'll be going over hypothesis testing and distributions and everything that goes in with that as best I can. That's a very big, complicated concept. But yes, thank you all for coming, and I'll hang out here for the next couple of minutes for any questions or comments.
And the registration link is in the chat in case anybody wants to register for next week. But thank you very much, Morgan. That was awesome. It was amazing.
Anytime, yeah. And Ryan, the recordings are posted on YouTube after the fact, I believe. I'm not sure where that bit.ly link is.
Yes. And that link should go right to our YouTube channel too, which this one should be up within the next day or two here.
Yeah. Ooh, Dana, that's a good question. That is something that is seen so rarely, because so rarely is your population like that accessible where you're able to survey absolutely everybody or everything in it. So I think in that case, you would probably just have like true population data. But if you're ever able to achieve that, I would love to know, because I don't think I've ever experienced that before. Yeah. Thank you all so much for coming.
Great job. Thank you, Morgan.
Thank you, Alex.